Hello, in this build we will see the care that we need to have when we use an asynchronic method inside a for each loop in C#. We will describe in here two different forms to manage they. Both forms are valid, but depend on the content of the asynchronic method what is better or not. The first approach to see is situate the await inside the for each instruction. This is normally the approach used in the case when the await is reaches the tree, the thread is free to continue and inside the loop the instruction executes each task one by one until the for each is finished and then the instruction continues to go to the end of the procedure. This meaning that inside the for each method is executed synchronic. The second option gives a better performance. We can create a list of tasks and use the Task.WhenAll after the loop is finished. In this case, the tasks inside the loop are executed in parallel and the time execution is drastically reduced. The procedure continues until the wait instruction, then the thread releases the control, and the procedure waits until the tasks are finished. Then the last instruction of the procedure is executed and the result is returned. This option, as you see, gives a real improvement in performance because create a real parallel execution of the task inside the loop, reducing the execution time and the time consumed for the more consumed tasks, and not by the sum of all execution time for all the tasks. But this method has limitations. If the second option with Task.WhenAll produce a better performance result, then why we bother to explain the first method? The response is that the Task.WhenAll option working OK only when the tasks inside the loop do not require a stricter execution order, or there are no concurrence between the threads when the data in the operation is accessed. Let's see this in detail. If you put the await instruction inside the loop, the tasks are executed in synchronic fashion with respect to the loop. The procedure continues to be asynchronic, and the control is returned to the program to do other action, for example, access the UI. But the tasks are executed synchronic, one with respect to the other. This guarantees that the tasks are executed in the same order that are launched, and then do not represent problem for concurrencing over the data or problem in the sequence of operation. The problem with this solution is it is slow. If you use the Task.WhenAll, this will be more efficient, but you don't have a way to know what iteration in the loop will execute first. This where very good is your task don't need strict sequences of execution or the data is not affected because the concurrence of the thread. Let's see in the code these two approaches. In order to demonstrate how it works, the two options that we have to run the for each with the await, we have three projects here, and the first project is to see how this works in independent tasks. The program is very simple. We have two calls. One that is repeated. This loop is because we need to see how the tasks different behavior in each iteration when we use this method and the second method. The first method that we use here is called with the way inside, and the second we're using the WhenAll option. Okay. This is a counter to have how much time we need to execute the operation, and that is the list of operation argument that we give to the method. Let's see the method itself. As you see, this is the method. The first method is called the await inside the for each. That's made this method run sequential inside the for each, and the second we create a list of tasks and we create all the tasks and then wait for the end, and that's it. The task is very simple. This is only consists in a delay to simulate more work and a console write line instruction that tell us um, the order that the execution of the task, the order of execution of the task. If we run this, you see this is the first loop. Each task is in the same order, 1, 2, 3, 1, 2, 3, and they use 3 seconds to execute because each task is more or less 1 second. And now you see when the task is using the WhenAll, the time is only for one task because all is executed in parallel, but we don't have way to find which task is executed first. You see here different order of execution. That's meaning that we can use this method if we need a very good performance, but it's not problem in the how the task is executed with respect to the other. So they are no order or they are no dependency, and then we can use this. Let's see now what happens when we have a concurrence problem. This is in this program. We have the same structure. Here we execute it in time. In the first time we are using the await, and in the second we using the WhenAll. The method that we're using internally. You see, we have exactly that we're using the other time. And here as the things WhenAll. Only now the task. This is a form to repair that we see later. And now we have the task. The task has one that simulate other process with 1000 here millisecond, but now it's a sum of total plus the value that's inside as parameter. That simulate a concurrence problem because this variable total is defined in 1 in the class, and this value can change. Can be affected by the order that the task is executed. Let's see this. And we are trying a form to eliminate the concurrence problem by create a semaphore. Semaphore can help us to this part of the code only enter when one thread per time, because we declare a SemaphoreSlim here, and we created in the constructor that only one thread at a time can enter in the application. Let's run this. That is the first method that's using the way. You see the total is 6 because we are soon 1, 2, 3, that's a 6, and the operation is 1 per second to do this, but the result is consistent along all the time that we executed the operation. That is because the tasks are executed sequentially. After that, we executed the task, and when we use the WhenAll, if you see this operation is correct, but here happens that the operation is altered because the order is executed the task. The third method that we are seeing here, you see now, is a form that we can repair the problem. And you see the time execution is low and the method is correctly, so the sum is corrected any time. You can do that, but not always. This method can work with the semaphore. Is only if you can first modify the task that you want to run. It's not something that is external to your code. And second, you can isolate the operation that you need to put the semaphore. If you put the away here, and then you don't get you don't win anything because each task is executed one-to-one to enter here, and you have 1 second for each task. And in this case, it has no sense to create the complication or the semaphore to do this. But if you can isolate the task, that is very good, and you have a very good performance, and you don't have concurrence problem. The third program I don't explain here, you can download the code, and it's when it's an operation that they are dependent, it should be executed in certain order, and of course has the same problem as the concurrence. As summary, use a way inside the ForEach when the task to be executed has data concurrence or has a strict order of execution. Is a solution with SemaphoreSlim not give you a significant gain in performance? Because the process to log is extensive in time, use a way inside the ForEach. Use Task.WhenAll outside the ForEach only when the tasks are independent and haven't any specific order of execution. This allows us to use the full power of parallel programming and get a better performance. Thank you for your attention. If this video was useful for you, please subscribe in our channel. More info at http://www.avalonsoftware.com. Thank you.